Hey folks, welcome back. It is Tuesday. I hope everybody had an awesome holiday. Happy Thanksgiving, and hopefully everybody's safe and had a great time. So we're going to get back into talking about sorting algorithms. We talked about searching algorithms last week. We're going to be looking at sorting algorithms, and we're going to be looking at the big three. There's a lot more than just the three that we're going to cover today, but par for the course. We don't have to go through every single one of them. All right, so first on the list, all right, we're going to just get right into it, is the bubble sort. So before we get actually into discussing that, if I kind of mentioned, I talked about sorting last week, and sorting and searching kind of go hand in hand with each other. There are some search features. We talked about the binary search and the linear search, and where the binary search was great to handle items. And it was quick to handle items. What we found out was that the items needed to be sorted in order to work through that properly. Where linear search, it doesn't matter. We can just kind of go through the entire list and find out or look for the information that we're looking for. But the problem with that is that it takes a very long time because we have to go through each item specifically. The binary search, however, we would have to sort the list. So that also takes additional time because we need to sort things first before we use them. So it's a sort of a give or take kind of thing. Does it make more sense to just do a linear search taking longer, or does it make more sense to use a binary search, which takes a shorter amount of time, but we have to spend additional time to make sure the list is sorted if it's not sorted? So it's one of those things where you have to kind of play around with and find out what is the best way of maximizing time so that your load times within an application are minimal. So anyway, the first sorting mechanism that we're going to talk about is the bubble sort. All right, and it is considered a comparison sort. And what we basically do is we have a list of items or just a number of items in general, and you spread them kind of out all over the table. Kind of put them in a line, if you will. And what we do is we start from left to right. We compare the first two items. And since we're going to do this in ascending order, we're going to find out which item is smaller. So we look at the first two items, and let's just say we had a deck of cards. And I got some videos I'm going to kind of play, and you can kind of see how this algorithm works out. But we look at the first two cards. Whichever item of the first two cards is smaller, okay, we put toward the left, and the larger one we put to the right. So if they're already going in ascending order from small to bigger, then you just leave them be. But if the smaller item is on the right and the larger item is on the left, you swap those two. You then go to the next two, all right? Do the same thing. Find out which one's smaller, swap it, put the smaller to the left, the larger to the right. You go to the next two, you go to the next two, you go to the next two, and so on and so forth. You keep doing that all the way to the end. Once you get to the end, you then pass through all over again to the beginning. And being that the leftmost card should, not necessarily, but should be the lowest card, you then keep bubbling through, comparing the two cards with each other. And then you keep going through the list again. You have to repeat this process n number of times until all the numbers have been swapped accordingly. All right, and what we see over here is the pseudocode algorithm for the bubble sort deck. So we place the unsorted deck face down in the right-hand pile. So you can, again, keep them all on a deck, or you can all spread them out. It doesn't really matter, but because you're always comparing just two cards. We have to repeat n number of times, all right? Which means we have to repeat however many cards are in the deck. That's roughly about how many times we're going to have to repeat the process. Put the top card of the right pile in your hand, and then we're going to then again have another loop, another repeat process, because we're comparing the two cards with each other. So this inner repeat loop, or this inner loop, is about comparing the two cards over and over again. This outer repeat loop is about going through the cycle over and over again until every single card has been sorted appropriately. And then you have the if and else statements, which say that if the card in one hand is greater than the other, then you basically place it to the left or on the top, and then or otherwise you have to, switch them, and you have to repeat the process all over again. All right, so let's take a shift over to, I have a video queued up using, oops, what the heck, give me a second here. Thought I had it. Oh, no, here it is. I have a video queued up, bubble sort video that we'll go through. So I'll be quiet initially, let this play out, and then I'll add some commentary in between. So as you can see, we're taking all the cards, putting them into a deck. Okay, we're picking up the first two cards, comparing the next two. The card that's lower, we're putting face down, and then the card that is higher, we're holding in one hand. And obviously, every card that we had there is lower than the queen, so that's why we drop it down, except that last card, which is the ace. And then ace being the highest, we place it at the top. We then compare the next deck, and then we're looking at dropping the lower cards while holding the higher card. We go through the whole deck, and we keep going, and we keep going, and then we place the high card down. Right, and then we go through the process again. Okay, we're looking at the cards, holding the higher card in our hand, and then comparing the remaining cards. And then when that is all said and done, we're going to take that card, place it face down, and repeat the process over again. So as you can see with this process, it does take a long time because we are constantly going through the deck over and over and over, because what we're trying to do is we're trying to separate the highest card with the lowest card. And again, the highest card we're holding in our hands, while the lower cards we're just basically discarding downward. And then again, taking the highest card and placing it into the discard pile at the end. And again, when you get to the same cards, like a 4 and a 4, or a queen and queen, it doesn't matter which one you throw down, because they're all going to basically be at the same, level of value in the end. All right, and that's it. And then when you're said and done, as you can see, we have the cards sorted in ascending order, going from lowest up to highest. All right, so that is basically how bubble sort works and how it goes through. So the video of that little card trick of 13 cards took just a little over 2 minutes. So kind of like with linear sort, bubble sort is a time-consuming process. It takes longer than other sorting algorithms because of the fact that you have to repeat through that loop over and over again in order to get the cards sorted into either the ascending or the descending order that you are looking for. All right, so the next one that we're going to look at is a merge sort. Okay, merge sort is considered a comparison sort as well, because what we're doing is we're rather than having one deck of cards, we're taking many, not so much decks, but many piles of cards, and we are going to merge them or combine them into one. I mean, that's ultimately what we're looking to do. Okay, so what we're going to do is we're going to start with one item in a pile, and then what we're going to do is we're going to start flipping and comparing, and through each pass, we're going to merge the piles into so the one individual will merge into two items in one pile, and then those are going to merge with the neighboring two items, which will create 4 items in one pile, and then those 4 will merge with another 4, which will create 8 items in a pile, and so on and so forth, until we have all the cards merged together. And the whole point behind that is that after the cards are all merged together, they should already be sorted as how they need to be. All right, and so what we're going to see is that the merge sort is going to be faster than the bubble sort by close to, not 50%, but probably like around 40% more efficient just through this little example than what we have with the bubble sort. Merge sort you can kind of consider slightly like a binary search because it has that divide and conquer approach where, remember, if binary search was we go right at the middle number, and then depending on if the target number is lower or higher, we then, take the middle number between the low and the high, the new low or the new high, whatever, and then we do the half of the half of the half philosophy. That's the divide and conquer approach. Merge sort works off of that same similar concept. So here's the pseudocode that we have for the merge sort. We're going to divide the cards into n number of piles. So if you have 13 cards or 20 cards or whatever the case may be, that's the number of piles you are going to divide into. And then we're going to use a loop, basically saying that until there is only one pile left containing all the cards, we are going to merge all the adjacent piles into new piles that are twice as big. All right, and as we go through that, we're going to be able to sort everything in the process. So let's take a quick look at a video dealing with merge sort. So as you can see, we're looking at 2 cards at a time. We're comparing them. We're placing the higher value card on top and the lower value card on the bottom. We're then going to compare the next 2 piles of 2. And we're going to drop the lowest card on the bottom while holding on to the highest card. All right. I'm going to go to the next pile, do the same thing. Lowest card on the bottom, followed by the higher cards on top. And then we are going to, obviously there's a straggler card, so we got to add that one in there. And then we're going to take the next 2 piles of 4 and combine them into a pile of 8 by always looking at the lowest card, dropping the lowest card down first. And then we'll combine the final 2 piles together. And that's it. Then we have our completed deck of merged cards from ascending order, lowest to highest. All right, so as you can see, much more efficient regarding merging and sorting, I should say, all your information. Again, different algorithm because we're not necessarily going through, only looking at 2 cards at a time, running through the entire deck, and then repeating the process all over again. We're sort of efficiently breaking it down so that we are combining more piles and more cards and kind of comparing more cards at one time. Even though we're still only comparing 2 at a time, but we're breaking it down into the piles more efficiently than what we had it with the bubble sort. All right, so the last one that we have is our bucket sort. All right, so not all sorts can be considered comparison sorts. A bucket sort is what we call a non-comparison sort. All right, which basically uses certain features that we have with previous sorting algorithms, but instead of comparing cards, what we're doing is we're basically placing the cards in a virtual or imaginary bucket. All right, and then what we do at the end is we will take them and combine them. So if you can envision in your mind, if you have 12 cards and all cards, they can range from any number, doesn't matter. But what you have in front of you are, n number of buckets. And then under each bucket, you're going to put like a little card. You're going to write a number 1 for the leftmost bucket, a number 2 for the next bucket, a number 3 for the next bucket, and so on and so forth. And as you go through the deck of cards, whenever the proper number comes up, so if the number 4 pops up, you're going to drop it in the 4th bucket. If the 8 comes up, you're going to drop it in the 8th bucket. If you have 2 more 8s come up, you're going to drop them in the 8th bucket, and so on and so forth. And you're just going to basically throw the needed cards into the proper bucket so that in the end, all you need to do is just dig into the bucket and you have all the sorted cards, and you can just go from left to right, ace, 2, 3, 4, 5, etc., and you can then stack them in ascending order as need be. What we find is that the bucket sort is the most efficient out of these 3 that are compared, just because of the fact that you are doing like the searching and sorting on the fly, and you are placing them and organizing them as you go along. So looking at the pseudocode that we see over here, for the bucket sort of deck of n cards, so we're going to create a for loop. So for each card in the deck, you're going to put it into the indicated bucket by its rank. And then starting with the lowest numbered bucket, you're going to collect all the cards when completed. And what it means over here by its rank is what I was just saying, how you just place a number in front of the bucket, and then that number will coincide with what number card you need to drop into there. All All right, so let's take a look at the video. Oops, wrong one. Where'd it go? Chrome. Here we go. All right, so this is a video of the bucket sort, and as you can see, we've gone from 1 minute and 20 seconds down to only 40 seconds. So definitely more efficient this way. So what he's doing here is he's flipping all the cards and he's placing them into their imaginary bucket. We're just sorting them on the fly. And so, you know, we're placing the cards so we can distinctly see exactly where they are and where they would fall in place. Similar cards we just stack on top of each other. And then once we are done with all the cards, we can now just collect them. He's collecting from highest on the bottom all the way up to lowest on top. And then we're going to compare them all so that they're in ascending order, starting from low, from the right, and increasing to the high on the left. Actually, that would be descending since the left side, but the other ones that we did had the other way. So anyway, so that is basically how we do the bucket sort, and how that one is a lot more efficient. But again, remember that when you know, depending on what type of information you're using, you're going to use a very specific a sorting algorithm, you know, for the data that you're using. If you're using like monster, like big data, out of these three systems, the bucket sort, sometimes they refer to this as, it's not the same, but it's very similar to what they call a radix sort. You might use something like that because it'll be able to handle and sort bulk data at a more efficient rate than some of the smaller sorting algorithms, or the other algorithms, I should say, which will take a much longer time in order to sort things out. All right, so what we are going to do right now is we're going to jump over to App Inventor, and we're actually going to build one. And obviously, for the sake of time, we're not going to build all three. What I'm going to do is we're going to build the bubble sort, and we'll put that together, and we'll show you exactly how the bubble sort would work within an App Inventor environment. Also, just so that you know, and let me see if I have, this over here. Yeah. So I'll post a link to this site. I thought it was just kind of neat. It shows us all the different type: insertion sort, selection sort, bubble, shell, merge, heap, quick, and so on and so forth. So there's no bucket sort here, but it just gives us, so if I play all, what you're going to be able to see is you're going to be able to see these are all, these lengths or lines of code that you see in each one are basically bits of data. And what we want to do is we want to sort them from, you know, smallest being on top to largest being on the bottom. So depending on how the algorithm works, as you saw with the bubble sort, you're going to see that the algorithm, it'll go quickly, so it's going to be kind of hard to see. But in this one over here, you're going to be able to see how I already clicked that one by accident. You're going to see how what they're going to do is they're going to go through each, you know, two at a time, and it's going to be comparing. And as you see, the small ones keep bubbling to the surface, and that's the whole point behind the bubble sort. You know, whatever target number you want to have come to the top, whether it be the biggest or the smallest, it's going to work its way by bubbling up, by comparing all the needed ones. So you can click on each individual one, all right, or you can click on, you know, the row, and you can compare all of them together, or you can go really crazy and you can click on all of them. And you can watch them all, you know, go ham all at once. But as you can see, some of them, like the quick sort, for example, you know, were much quicker. Bubble sort, selection, and insertion obviously finished much slower. So it just goes to show you that there are algorithms that are more efficient with handling data than there are others. But again, keep in mind that it really comes down to the type of data that you are trying to put together. All right. So that being said, let's jump into App Inventor and let's put together this bubble sort. What I'm going to do, because I know I probably will run out past the 30-minute time, I'm going to put the user interface together, and then what I'll do is I will stop the video, create another video, and another video will be putting the code together. All right, so I already started a new project. I called this bubble sort. What I'm going to have for this is I'm going to keep the UI very simple. All right, I'm not going to have anything crazy over here. What I'm going to do in this is I'm going to use the list view. All right, so it's just a new component that we're going to have. All right, and the list view is going to allow me to be able to create a list of information and display it within the user interface. In this case, the list I'm going to display is going to be just a group of numbers. All right, so that being said, I want to change some of the properties of this because it's too small for my liking. So I'm going to go over here into the height and width, and I'm going to change this. So the width I'm going to keep, the height I'm going to change to 300 pixels, so it spans most of the screen. And the width I'm going to just choose fill parent, just so that I know it's always going to stretch across to the right. And then what I'm going to, actually, you know what, I can maybe make the height a little bit more. Let's switch that up to 350. All right, that's better. And then what I'm going to do is on the bottom here, I'm going to come down here to my layout, and I'm going to grab a horizontal arrangement. I'm going to drop a horizontal arrangement in here, and the same thing, I'm going to do a fill parent on both the width and the height so that it scales to the size what's remaining on the screen there. And then what I need to do is I'm going to drop 2 buttons within here. So I'm just going to back to back, drop first button, and then the second button. So what I'm going to want is the, doesn't matter how I do it, but what I'm going to do is the button on the left is going to be my start button, because that's the button, or my sort button, because that's the button that I want to have sorting all the information. And then the button on the right is I'm going to have like a random generation, because I want to, rather than having just a hard code numbers in here, what I want to do is I want to make sure that the numbers that I put into my list view or my program here are going to be numbers that are randomly generated. All right, so with that being said, let's click on the first one here. Let's get rid of text for button 1. And I'm just going to type in sort now. And then text for button 2, let's get rid of text for button 2. And let's just type in generate random numbers. All right, and I don't have to, I mean, if you really want to make it look, you know, neat and nice, you know, you can space these out, but I don't need to do that. I'm just going to leave it as is. What I do want to do, though, is I want to change the names over here, because I don't want to keep them generic. So button 1, I want to rename to button sort, and hit OK. And then button 2, I'm going to rename to button random. So I know that's my random numbers there. All right. And with that being said, I think that should be good to go. What we're going to do is in the code we're gonna populate we're gonna use, like we did with the other list picker, how we had to use the elements. We're also going to use the elements set elements code in order to populate the numbers that we have in here. All right, so let me check out my time here. Yeah, I'm at 23 minutes, so let me stop the time for right now. This is all we need to do for the user interface. Like I said, very clean, very simple, but it's going to be the code that we're going to be focused more on. So I'm going to stop here, and we will see you in the next video. See you soon.